Hello guys, Mrs. Levenseller here. I'm going to give you a few notes for assignment 9, which deals with the sums of arithmetic sequences. So we're going to start by talking about a famous mathematician and physicist named Gauss, Carl Friedrich Gauss. And a while ago, he was asked to add up the numbers from 1 to 100. And probably this was his teacher giving him some busy work, So they said, stay out of my hair, go add up the numbers from 1 to 100, and then come up and see me when you're done. So he sat down, started adding, and was like, man, there must be an easier way to do this. So instead of jumping right in, he thought about it for a minute and said, all right, what if I try and line up the numbers backwards and see if anything jumps out at me? And so he's doing this all the way down. And then he takes a look and he says, well, if I add 1 plus 100, I get 101. If I add 2 and 99, I get 101. And wouldn't you know, if I add 3 and 98, I get 101. 4 and 97, I get 101. That works all the way down to the end where I have 99 plus 2 is 101. And 100 plus 1 is 101. So it's a lot easier to do some calculations if all of your numbers are the same. So he looked at this and said, okay, well then I have 101s. But because he actually added 2 rows of 1 to 100, he's adding them twice. So in order to account for that, he has to divide by 2. So he figured out what this was, and he went up to his teacher, and they were like, how did you do that so fast? And to explain his thought process, he generated this formula, which is for the sum of arithmetic sequences. And remember, arithmetic just means that there's a pattern of addition. So 1 to 2 to 3 to 4, you're adding 1 each time. That's arithmetic. There's a spot for this formula on the back of your sequencer as well, so I would make sure you fill that in before your test. So to generalize what he actually did, well, the first piece here is 100 divided by 2. Well, the 100 came because we have 100 numbers. So if I'm going to make a more general equation, it would be n over 2, because I've counted them twice. And then to get 101, we added corresponding terms when they were written forward and backward. So if I want to make this the most simple, I can maybe think about these two down here. Well, 1 was my first term, and 100 was my last term. So a sub 1 plus a sub n. And because you get the same sum all the way down, it doesn't really matter which one I started with, but using a sub 1 plus a sub n is probably the easiest way to figure that out. So this is the formula that he came up with for the sum of an arithmetic sequence. All right. So let's say I give you the values 8, 20, 32, 44, etc. And I want you to find the sum of the first 10. And so it's going to be written just n equals 10 is what we're looking for. So we have to find 2 pieces of information when we do this. First, 3 I guess. We have to know what n is, and so n is equal to 10. If I think about all the things I have to fill in my formula, I need n. Then I need a sub 1, and so a sub 1 in this case is going to be 8. Remember, we're assuming that we're given the first term unless they say otherwise. And the third piece of information we need to know is a sub n, right? This piece down here. That's the piece that's a little trickier to find. But if you recall, this sequence is arithmetic. So I can go back to my other formula and figure out what is the 10th term here. Well, the first thing I need to know is what's the difference? What's the common difference? It looks like we are adding 12 each time. So a sub n is going to be equal to 12 plus n minus 1. Usually we leave that, but if I actually want to find the 10th term, I'm going to put in 10 for n. And the common difference, oh, I'm sorry. I made a mistake. This does not happen all the time. The first term is actually 8, so that's what should be in a sub 1. The common difference is 12. So if I simplify this, I have 8 plus 9 times 12, and that should give me 116 altogether. So that is my a sub n in this case. So now if I go and fill in that whole formula, we're going to have s sub 10 is equal to 10 divided by 2 times a sub 1, which is 8, plus a sub n, which was 116. And now that's a simple calculation. 5 times 124 would give me 620. So that process was a lot quicker than actually sitting there finding all 10 terms and then adding them up. And okay, maybe 10 terms isn't that bad, but if I asked you to add up the first 100 terms of this sequence, you could be sitting there forever finding all those terms and then going ahead and adding them up, and there's a lot more room for error. So with this handy formula, all we have to know is these three things, n, a sub 1, and a sub n, and we can figure out what the sum would be pretty quickly. But remember, this only happens if the sequence is arithmetic. Okay, so if you see a sequence given to you with a pattern of multiplication, or if it's a sequence that was derived from n squared, then you actually have to find the terms and add them up. But here we can, if it's arithmetic, we can use this little formula. That's very helpful for us. All right, so let's look at one more example here. So I'm going to give you the sum, because that's what we're really doing, so a summation, from n equals 11 to 50 of 3n. So the first thing you want to think is the sequence arithmetic? Well, the formula that they've given me is 3n, and if we're starting to write out the values, well, if we start with n is 11, we'd have 33, and then 3 times 12 is 36, 3 times 13 is 39. Well, yeah, there's a pattern of addition, right? And anytime this looks linear, that's going to be an arithmetic sequence. So we can check off that box. It is arithmetic. Once we know that, then we have to find n, we have to find a sub 1, and we have to find a sub n. So in this case, n is how many numbers we are actually adding. How many terms are we adding? So if I go from 11 up to 50, that would be actually 40 different numbers, right? If you think about counting, if I go from 1 to 10, that is 10 numbers. But if I go from 0 all the way to 10, that's going to be 11 numbers. So anytime your initial value starts on a 0, you're always going to add 1 to how many you would think there are. And if it begins on a 1, then we're going to have an even number like 10 or 20 or 30 or 40. So we're going from 11 to 50, so my n is 40. My a sub 1, well, in this case, the very first term is going to be the a sub 11, and a sub n is going to be a sub 50. So a sub 11 would be 3 times 11, which is 33. And a sub 50 would be 3 times 50, which is 150. So now if I go back to my formula, s sub 40 is equal to n over 2, so this time we have 40 over 2, times the first term that we want to begin with is 33. Oops. Technically our 11th term here, but it's the first term that they are telling us to start with. And the last term, a sub n, is 150, right? So 20 times 183 is something we can figure out. I don't have a calculator handy. But that's how I would come up with the sum if they gave me this summation notation. So go ahead and see if you can figure out the problems from assignment 9. And then when I return back to school on Tuesday, we will take a look.